Last time, yesterday, we installed Docker scripts, and then we are working on this directory /var/test, and then in this directory we have created this subdirectory that contains the scripts, and then we have installed two applications that are based on these scripts. And on these scripts, we have a Docker file which defines how to build the image for these containers. And then these settings, actually a copy of this is made to these applications. And here it contains a variable that has the path of the scripts. So where the framework is going to find the scripts. And here we also have defined some commands. For example, the command hello. If I type ds hello in the directory of one of these two applications, then the framework is going to figure out that there is this file here, which defines a function here. So the framework will find this file, and inside this file it is going to expect a function named like this, cmd underscore and the name of the command, and it is going to execute this function in order to run the command hello. And it is going to pass all the arguments to this function. So if I say ds hello and argument 1, argument 2, argument 3, some arguments, then these arguments are going to be passed to this function. And in this case, this function is using only the first argument, which is the name, and it is printing some message. Now I can also extend this with some with an help function. So I can define a function which is showing the help for this command. So this function is showing how this command should be used. So let me save this, and if I type ds help, then it is listing it is showing how this command ds is used. So ds, we have seen this before, and then it has these subcommands: pull, init, info, build, create, config, inject. These are all defined by the framework, and also the command ds shell, ds exec, ds snapshot, ds remove, etc. but it is also listing these commands that have been defined by the scripts. So we have defined the config. So we have defined this config, which is overriding the DS config of the framework. And we have also defined this hello, so it is listing this command as well. But this one does not have an help function, so it is just showing the name and no usage. For this command, this has the help function that we just defined, and it is showing how this command is being used. So we see that it is taking one argument, and it is doing this: print a greeting from for name from the container. This hello, and then a name. It is expecting a name. And if I run this command to another container, then it is executing this command ds hello into the directory of this container. So it is saying hello from container up to. Now the last thing that we are going to do here is that I'm going to customize the command ds hello for this application. So I'm going to override the definition of command ds hello. It is defined on the scripts, but I'm going to make another definition here for this application, and then the framework is going to use the one that is defined by the container. So I will create another directory here named cmd, and then I will create another file cmd hello. .sh, and then here I'm going to define the function cmd underscore hello, but I'm going to do something else first. So the function cmd hello has been defined already by the scripts. So before redefining it, before overriding it, I'm renaming the function named cmd hello, and I'm assigning it this name, scripts1 cmd hello. This is the function defined by scripts1. And then I override this function. I make a new definition for this function, which will override the previous definition. And inside this function, I call the command dsinfo, which is going to display some general information about this container or this application. And then I call the default definition of this cmd hello from scripts1. So this is something like extending the definition made by the scripts. And this rename function is defined by the framework. We can see it, for example, here we are at the at the directory where the source of the framework is downloaded, and there is this function auxiliary, and here there is this function rename function. So we are creating this function which changes the name of a function. Now let me try this hello here. So this time, when I run this command ds hello, it is executing this one, the command that is defined in this function, in this file. And the definition that we made is that we call ds-info. ds-info is displaying this information. And then we are calling the definition of the command hello from the scripts. But it is requesting a name here, so it is just displaying the usage. So let me try with I've forgotten something in the definition, because I should pass to this function all the arguments that are passed to this function. So it should be like this. So this is saying pass all the arguments. So this is a special variable in Bash that contains all the arguments. So I'm calling this function with all the arguments that are passed to this function. So let me try again. So now after this info, I get this message from the other command, hello-amir from container app1. And if I call this on the container app2, it is still the same message, because this container has not defined its own version of command hello. It is using the version that is provided by the scripts directory. Okay. Now, in these examples that we have done so far, we are defining locally the scripts, but usually the scripts are defined in a GitLab repository, and we can pull them from GitLab. And we can do it with the command ds pull. For example, I can pull the scripts for Debian. There are some scripts for building a Debian container, and it is basically a git clone. So it is cloning the GitLab repository into this directory. So if I change the window, if I go to the other window, now I also have this directory which was pulled from GitLab. So the origin is this URL, gitlab.com docker scripts Debian. So what is the content of this repository? We have this file, Docker file, which contains the definition of the image, how to build the image for these containers. And then we have these settings. We have seen these two already. And then we have this directory cmd, which defines how to create the container and how to make the configuration of the container. And also we have this inject directory with the script set up. And let's look one by one. So it is starting by using Trixie as a base image. So I explained it last time as well. This is not a Docker script syntax. This is a macro syntax. We are using M4 macro. So we are using this macro, M4. Or the framework is using it, because we don't see how it is being used, but the framework is using, behind the scenes, is using this macro. And this is actually including another file from the framework here, which is Debian Trixie base image. And then we are running this command, which is installing something else on top of the base image. So we are installing OpenSSH server and Python 3. So settings, this is the directory where the scripts are located, and these ports will tell the framework which ports to forward to the container. So in this case, it is forwarding the port 2201 from the host to the port 22 of the container. And let us look at this command, create. So it is using the same trick that we saw before, rename function cmd create, because this command create is already defined by the framework, but we are renaming the default function to this one, and then we are redefining it here. And in the redefinition, we are calling the original function, but and passing all the arguments. So in this case, this does not extend it actually, but just as an example. And let's see at this config. The configuration that we do inside this container is just calling this script setup, dsinject setup. So this dsinject is copying this script into the container, is placing it inside the container, and then it is running it. It is executing this script. And the script setup.sh that is injected is found into this in this directory by the script, in the directory inject. And this script is making an initial or is customizing the configuration of the container. So what does it do? It is generating an SSH key again without password, but it is generating it only if it does not exist already. So it is checking whether this file exists, and this file exists, or generate it if it does not exist. And then it is copying the public key to authorized keys. So copy sshkey.pub to these authorized keys. Make sure the permissions are correct. And then it is modifying also the SSHD config. So permit root login is disabled permit root login without password. It is not disabled actually, but the password login is disabled. So the root can log in, but not with the password. It can log in with this key that we generated, and then restart SSHD. So we have built a Docker container like this before, and this container allows us to log in into this container with SSH on the specified port. Now these are the scripts. How do we build a container from these scripts? Let's go to the other directory. First of all, we initialize the directory of the script of the container. ds init debian at server 1, or let's call it deb1. So we have seen this command ds init before, and this is showing the syntax of this command, or how it is used. So this is the directory of the scripts, and this is the directory of the container, the location of the container. But there is something specific. So if the directory of the script does not start with dot slash or dot slash or this slash, then it is using this directory as the base directory. So it is looking for, so the command that we used ds init debian. This debian, it is trying to find it inside this directory. Why? Because it does not start with slash. So if it was like this, it would try to locate it into the current directory. Or if it was like this, or another path, for example, if it was like this, it would try to locate it to this path. Or if it is an absolute path like this, it starts with a slash. But this one does not start, it is just a name of a directory, and so it is trying to find it into this directory, /opt/docker scripts, which is the directory where we cloned the script from the Docker, from the GitLab. And the same for this one. If it starts with a dot slash or dot slash, or if it starts with a slash, which is an absolute path, then it is going to locate it relative to the current directory or as an absolute path. But in this case, it does not start, so it is trying to, it will create the directory. It will initialize the directory into this /var/ds, and the message here from the command is container initialized on the directory var ds deb1. So let's go to this directory. And we see that the command init has copied these settings here. And here there is always this variable app, which shows the location of the scripts. And again, the location does not start with dot or it is not a relative or absolute path, so it is going to find it, the scripts, to the directory /opt/docker scripts. So it is going to find it into this directory. So this is the kind of default location for the scripts. And here we have the name of the image, which is the same as the name of the directory of the scripts. It is the same as the name of the directory where the scripts are located. And here we have the name of the container, which is initialized as the name of the directory where the container is located. And there is also this ports, which is actually which was present also on these settings. So it is from this line. And we are forwarding the port 2201. We are instructing the framework to forward the port 2201 to the port 22 of the container. So let's build the container with dsmake. Right now, it is the process of building the image. It is building the image for this container. But we see some error here. No, this one is not important. Here, there is an error here. And it says bind for port 2201 failed. Port is already allocated. And actually we have built a previous image and it is still running on this port. So we see that the port 2201 is already being forwarded to, or it is already being used by another Docker container. So I can stop this one and then try to build again the container deb1, but I can also modify the port on settings. So let me modify the port on these settings. So I'm going to use this port, which is free, because the other one was already being used. And try again dsmake. Why it is taking so long? Let me stop it with Ctrl C. I don't know why it is taking so long. And let me actually okay, it is the debugging is enabled. So I was trying to enable it. So let me try again. is executable, but so this inject is actually
you could do a test whether if you return to the port 2201, killing the other SSHD.
yes, Tony, but I don't think that is the issue. I can stop the other container and try the other port, but I don't see why it is the issue here. It is not the issue, I think.
Just an idea.
Yes,
Okay.
you are right, but I'm almost sure that cannot be a problem. But I see this local error 150 here. I don't know what it means. So let me try to search for this error. Yeah, maybe it is this one that we have lots of containers running and it has reached the limit. So I will stop some of the containers and try again. So let me stop some of the containers. Actually, we have lots of them. So let me stop this one. And what else? I can stop WordPress 1. I can stop these test applications, app1, app2, that we started last time. Let me stop db1 and this and this. And let me try again. I don't know. I will restart. I will restart the server and try it again. So let's wait a couple of minutes. Let me go to var ds. It is working this time. I'm not sure what was the problem, but most probably the server was overloaded somehow for some reason. So it is running this script, inject setup.sh from the directory of the scripts. And we can see what the script does here, but if we list the directory, we see this SSH key, which we can use to SSH into this container. And the port that is being shared is this one, 2202. So let me try to SSH. SSH port 2202, identity file, this one, SSH key, and then root at localhost. So I'm connecting to the localhost, but this port is forwarded to the port 22 inside the container. So let me try this. And I am inside this container. Now let me try to do the same thing from outside the VPS. For example, from my PC. So or let me use Vim to copy it. deb1.key, and I'm going to copy this key, copy and paste, but I can also do it with SCP. So let me do it better with SCP. So if I can do SSH VPS1, I can also do SCP VPS1. But SCP VPS1, what is the path of the file that I'm going to copy? It is this one. So Ctrl-Shift-C, I'm copying it, and Ctrl-Shift-V, pasting it, and also this file here. Copy, paste, and I will copy it to the current directory, but with the name deb1.key. I think it was copied. Yes, it seems that it is copied correctly. And let me check also the permissions, because they have to be restricted. Yes, it is read-write only for the owner, and the group and the others don't have any permissions. So now I can do an SSH port 2202, identity key this one, and then the user root at the host name is, let me call it deb1.user1.fs.al. Yes, and I'm inside the container, so it is working. Now let me build a second Debian container, and I'm going to initialize a directory for the second container, ds init debian. This is the name of the scripts directory, at deb2. I'm calling this one deb2. And now go inside this directory. I will modify the port here because port 2201 is already used, and 2202 is used by deb1, so I'm naming it 2203. And ds make. And it again is generating this private key that can be used to SSH into this Debian container. And let me test it locally. SSH port 2203, root at localhost, and I'm inside this container deb2. Now let me build an Ubuntu container. First of all, I have to pull the scripts for building an Ubuntu container, because I have the scripts for Debian, but I don't have the scripts for Ubuntu. So I already have the scripts for Debian, but I need the scripts for building an Ubuntu container. And it made a git clone from the GitLab repository, from the corresponding GitLab repository. And these scripts are actually very similar to the Debian scripts. If we look at Dockerfile, we will see that it is based on Ubuntu, on the latest version of Ubuntu. So it is including Noble in this case, which is the latest version of Ubuntu. And then again installing OpenSSH server and Python 3. And the rest is almost identical with the Debian container. So after pulling the scripts, I'm going to initialize a directory for the container. ds init Ubuntu at Ubuntu 1, for example. I'm going to modify again the port here. And then ds make to build a container. it is building this image for the first time in this machine, so it is taking some time. If I try to build it for a second time or a third time, then it is going to use the cached image, the image that it has already cached. Again, it is generating this private key and public key, which we can use this private key to SSH into this container. SSH port 2204, identity file SSH key, root at localhost. And we are inside this container. Now let's do another example, a similar example. Now, if we see the syntax of the command dspool, it is taking an argument which is the name of the application that is going to be, or the name of the scripts that is going to be cloned from GitLab, and it takes an optional branch. So if this repository has some branches, we can use one of these branches. For example, the Debian repository also has a branch for bookworm. So the default branch is Trixie, the latest, but bookworm is the previous version of Debian. So if we want to build an image for this based on the previous version of Debian, then we can use the branch bookworm of this repository. And we can do it like this, dspool, this is the name of the repository and this is the branch. And it says cloning into this directory. Branch bookworm not found, like this. Okay, it is like this. So it has cloned the branch into this directory in opt docker scripts. And now let's initialize a directory for this container, ds init. This is the name of the directory of the scripts here. And then the directory of the container, deb3. Let's use another port here. And then build the container. So this error message here is not important because up to here it is building the image, and then it is trying to remove the existing container before creating the new one. But there is no container named like this because this is the first time that we are building this container. So that's why we see this error message here. This is not important. It tries to remove it first and then create a new container with the same name, with this name. But first time that we build the container, there is no such container, so there is nothing to be removed, and this is the error message that is shown here. And again, we can use this to SSH, but I can also do an SSH shell, and just to check the version of Debian. So at this configuration file, we can see the version of Debian, and it is Debian 12 bookworm, the previous version of Debian. Now the last example for today, we will build another container, a Debian container, but this time we are not going to use ds pool, because ds pool actually does a git clone. We can do a git clone manually. So let me go to this directory, opt docker scripts, and let me use git clone https gitlab.com docker scripts Ubuntu branch Jammy. And let me save it to the directory So I am cloning this repository into this directory, but using the branch Jammy of the directory. Jammy is the previous version of Ubuntu, not the latest version. The latest version is Noble. This is the previous version of Ubuntu. So if I check with the command git branch -a, I see that it is at the branch Jammy here. Now I will initialize another directory for this container, ds init, and this is the directory where the scripts are located, and I will call the name of the container just Jammy or Jammy1. Go to this directory, modify the port, and build the container. let me try to SSH. So the port is this one. And it is Ubuntu 22.04, which is codename Jammy. And before we close before we stop for today, let's clean up these test containers that we created. So all these test containers that we created, we can remove them. Let me start by this one, because we are already on this directory, and ds remove is going to remove the container and also the image. And now I can remove this directory as well. And let me do it for these other containers. This is not correct. I should do it without these double quotes. Okay. Now I go to the directory var ds dir, and then I run ds remove. And now I can remove all these directories. So we did some cleanup, and we can also do to clean unnecessary images and containers. So the images that are not being used, and the networks that are not being used, and the containers that are stopped, all of them are removed or are cleaned by this command, docker system prune.